Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of domain and range. This is standard A.2A in the great state of Texas, and we are using item number 33 off the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a graph here and we need to find the one that best represents a function with a big word here, domain, all real numbers less than or equal to 6. All right, so let's see if we can put that into an inequality here. Domain is all real numbers less than or equal to 6. All right, so we need to know what that domain means. Unfortunately, domain and range are not defined for us. So we need to have those already in our mind before we come to this test. So let's go and define those real quick. So the domain is the set of all independent. So we always start with our independent variables, independent variable values. For most of us, it's going to be our x values. Every once in a while, they will give you a problem in which they replace the x with a j or an r, t, something like that. So then the range is what goes with it, and if the domain is the set of all independent variable values, then the range is going to be the set of all dependent variable values. Mostly those are the y values. Sometimes it's f of x, sometimes it's a different letter. So we're looking for the set of all independent variable values. So for our purposes here, we can look for our x values because this is just a standard coordinate plane and they have the x and the y axis already aligned for us and clearly labeled on all of our problems. So let's just look to see each of these. We have array. So we have a starting point. Notice that each of these starting points has a closed circle rather than an open circle. Closed circle means we are going to include whatever number that is. So we're going to do greater than or equal to or less than or equal to. If it was open like this, then we would do just a greater than or less than, not equal to. So let's look at this A. And since we're looking at the domain, we're looking at the x value. So I'm just looking at this x-axis, okay? So it starts, so I'm just going to say x is less than, because it's starting here at my 6 and going to the left, so it's less than or equal to 6, because it starts at the 6, including 6, and it goes down to 5, 4, 3, but it's a continuous data set because it's a line. Sometimes we'll get little dots, and it'll just kind of be like some dots. And those are discrete. That means they're just like counting numbers. This is continuous. So that looks like that's exactly what we're looking for. It looks like it's a domain less than or equal to 6. Let's make sure that we got this one correct. Let's check B. So x is now looks like it's going to the right, so it's going to be greater than or equal to, that looks like -4. Not even close. But you know what this one is? Here's the trick. Check out the range. The range, remember, is our set of y values. So this is y. Look at it, starts at 6 and it goes down. Y is less than or equal to 6. So if I didn't know the difference between domain and range, B, I see, might be able to trick me. C, unfortunately, we just didn't get the less than. So x is going to start at 6, but it's going to be greater than or equal to. So it's just the wrong inequality, not what we're looking for here. And then the same thing happens with D. Really, there's not many other ways to do it. Our domain is going to be less than or equal to 3 because it starts right here, goes to the left. It's that range is where it starts at 6. But even then, it's not less than or equal to 6. It starts at 6. Now I'm looking at the y values, and it goes up. It's greater than or equal to. So my answer is A.